Um, First of all, this is the best weekend of the year, every year, and I want to thank Dale for this. I wouldn't be here if it weren't for him. So as he said, in December I quit my job as editor of Wired, which I'd done for 12 years, to basically follow my heart and industrialize my hobby, as I put it. And I just want to tell you sort of a quick story of basically a 3-year progression through all those steps that Dale just mentioned. The community, the maker to maker, and then finally maker to market. And I ended up just starting with my children and ended up with, well, you'll see in a second. I'm going to show you a couple pictures, and then I'm going to tell you sort of the lessons that we learned on the course to scaling this hobby into a proper company. So today I'm CEO of 3D Robotics, and I'm going to take you from Lego to Tijuana in about 6 slides. 5 years ago, I was trying once, as always, to get my children interested in science and technology. I have 5 kids. There's not a geek amongst them, but I'm not giving up. I continually try to find projects that will get them interested in science and technology. And I even started a site called Geek Dad, and the editor of Geek Dad, Ken Dinmead, and some of his team are now here, specifically to come up with projects that would be cool, be fun for parents and fun for kids, you know, not one or the other, but both. And this backfired in 2 ways. One is that my kids refused to go to the site because it was my thing. And second of all, anytime I did a project with them, they accused me of doing it for the site. It's like, are you putting this on Geek Dad? And so they won't even let me come near them with a camera anymore. Anyway, 5 years ago, they had not yet become quite as sophisticated about my devious plans, and I got them to do one last project with me. I says, we're going to do Lego robotics. We're going to do like a Mindstorm. So we're going to build a robot. And we built the Tribot, which is what you do out of the kit. And they were like completely unimpressed. It is a 3-wheeled robot. It just, you spend all morning building it and programming it, moves to the wall, and then detects the wall and backs up. And they're like, we've seen Transformers, right? Where are the lasers? This sucks, right? You cannot compete with CG. I mean, Hollywood is very tough in terms of the kind of wow factor in robotics, and real robotics is hard. So I tried to think of something that would impress them, and I thought, well, what if the Lego could fly? That would be cool. And so we built this. This is the world's first Lego Autopilot. And I had to like Google Autopilot, and I had no idea. But it just struck me that there was something kind of amazing about the fact that, this is 5 years ago, that you could buy these bits of plastic, this kit, with these sensors, these accelerometer and gyro and compass sensor, and it had Bluetooth, which could connect to a GPS device, and it had an ARM processor, and I was like, toys have gotten more interesting. What's going on here? How is it possible that my children and I can build a Lego Autopilot on the dining room table after Googling Autopilot? Isn't this supposed to be military-industrial technology? Later on, we found out that, in fact, it is military-industrial technology, that autopilots are classified as cruise missile controllers, and that technically we weaponized Lego. But we didn't know that at the time. What we knew is that this is one of those spooky moments, and it was spooky in 2 ways. One, it was spooky that it should not be possible for children to build autopilots and drones. And this, by the way, we put in an airplane and it looked like this. And this is now in the Lego Museum in Billund, Denmark, the world's first Lego UAV, unmanned aerial vehicle. It should not be possible for children to build drones out of Lego. And so what made that possible? And secondly, Lego may not be exactly the right technology, but if it is possible for us to build drones with Lego, what else could we do on the dining room table? So the simple answer to the first question is why was it possible 5 years ago for us to do this, is basically this, the so-called magic in your pocket. The smartphone revolution is not only transforming computing on the go, but also creating a class of components that are in some smartphones that are now accelerating at a pace we've never seen before. So these are the MEMS sensors, the gyros, accelerometers, compass sensors, the barometric sensors, the GPS, the cameras, the ARM processors, the wireless, the battery power, all that stuff that's now operating at sort of Apple and Samsung economies of scale are now generating these components, making these components available to all of us for just a few dollars. Gyroscopes used to be like this big and cost like $40,000, and they were just for the military. And today you can get 3-axis gyro, 3-axis accelerometer, 3-axis magnetometer, and a processor on one chip the size of your fingernail for about $4. That is one of those moments, much like, I think it was the Intel 8080 that triggered the Apple, the Homebrew Computing Club. Anyway, the availability of a formerly unobtainium component to the public allows these bottoms-up innovations to happen. And in this case, what we realized is that these components were fantastic for robotics and aerial robotics in particular. And this was a slow realization for me. I didn't know why it was possible for LEGO to do this. I later discovered that it was what we call the peace dividend of the smartphone wars. That the Moore's law of components in a smartphone were creating an enabling technology, or a suite of enabling technologies that allowed us as individuals, as communities, as amateur, to do things that were previously only the military, industrial, defense contractor stuff. So again, I knew nothing about this. This was me on a dining room table sort of saying, holy cow. The children lost interest instantaneously. I went right down the rabbit hole, and I created a website. So my big sort of lesson from the web era is that it's okay to be ignorant in public. When you're ignorant in public, and when I say ignorant in public, I mean I created a website and I started asking dumb questions and posting my discoveries, as banal as they may be. When you're ignorant in public, two magical things happen. Number one, when you ask dumb questions, people will answer them, and you'll get smarter. And number two, it liberates other people to ask dumb questions of their own. And it turns out that in a new industry like this, in a new kind of bottoms-up experiment in, let's say, democratizing formerly industrial technologies, or commercializing, or demilitarizing formerly complex technologies, what you end up having is an incredible suite of disciplines that have to come together. You've got analog electronics and digital electronics and aeronautics and computer science and design and documentation and applications, and nobody is expert at all of them. And what a website like this and any other community allows is for people to bring their own expertise to this community and then ask dumb questions about things they don't know about, and then come together to collaboratively do things that no single one could do on their own. So today, we're one of the biggest robotics communities in the world, and we've essentially assembled an aerospace company online in the open for free. And we are today doing the kind of things, actually we're not only doing what the Boeings and the Lockheed Martins do, but we're doing things they don't do, because big defense contractors serve their customer, which is the government and the military. And we serve our curiosity. And today what we've created is a universal autopilot. It's a box, costs $170. And you put this box in any vehicle and it becomes autonomous, fully autonomous. An airplane, a helicopter, a multicopter, a car, a boat. This has never existed before. It's never existed because the government never asked for it. But it could exist because it uses the same technologies. It's just a matter of code. And this community, liberated to scratch their own itch, designed it. So that's how we got started. We got started with a bunch of people who are expert on one thing, coming together to learn from people who are expert in other things, to collaboratively do things that used to require an aerospace company. A couple years ago, Dale was kind enough to feature us on the cover of Make, and I just want to tell you the story of this guy here, Jordi Munoz, who was one of the first members of our community. As I was sort of posting dumb questions and discovering things that anybody who knew anything about this would have already known, this guy comes on the community, and he posts this YouTube video of him flying a helicopter with a Wii controller. This is about, I'm going to say this is about 2007. And not only did he post a video of something that was pretty cool, but then he posted his code, and he explained his code. And what he'd done is he'd basically taken the Wii controller, which had the accelerometer, and then he'd hacked a radio control helicopter, and he'd used something called Arduino to connect the two. And I'd never heard of Arduino before. And so he said, it's cool, it's open, It's very easy to use, and you should try it. And I said, thank you. And then he said, and here's how the code works, and it's called a Kalman filter. And I had to Google Kalman filter, and it's about sensor fusion. I had to Google that. And he then documented it, and he seemed to be the smartest guy in the world. And so I said, you're awesome, Jordy. Let's do some projects together. So we did a blimp. We did a couple other things. And then I said, and then we started posting our design files. And we said, well, here's how you build do-it-yourself drones. Here is the printed circuit board, the Eagle file. You can have it fabbed. And here are the links to DigiKey, where you can order the components and then solder them together. And here's the code, and here's how you compile it. And a small number of people said thank you, and a large number of people said, could you just do that for us, please? We just want to buy it. And we said, gosh, that's kind of a good point. If we really want to start something here, we have to lower the barriers to entry. We have to make it easier to pick up, which means we need to do it for people, which means we need to create a company. So I said, Jordy, you seem to be the smartest guy around on this. You want to start a company? And he said, to my surprise, sure. And I said, awesome. Tell me something about yourself. I never met you. And it turns out that when he had first posted that video, he was a 19-year-old high school graduate living in Tijuana, Mexico. He's from Tijuana, and he had kind of dropped out of college and was kind of bored. And so he was just hacking a radio-controlled helicopter, and that was 2 years before we started a company together. Today, he's president of a multi-million-dollar aerospace company. He's now 25. He still hasn't been to college. But the point was simply this, that the traditional 20th century forms of finding talent and hiring people and selecting your co-founders would not have selected Jordy Munoz. But the Webb's innovation model, the community-based one, selected him as being the right guy for the job. He was the smartest person at this particular job, which is to say that he understood three important things. He had a kind of an animal instinct for the technology. He understood Arduino. He understood openness. He sensed that the Moore's law of MEMS sensors were taking us in a direction that was going to lead this bottoms-up innovation. He also was fearless and would just do things, not just post videos, but also ultimately, as you'll see in a second, create factories. And thirdly, he was from Tijuana. And I'll explain to you why that's an asset in just a second. So we agreed to start a company, and I said, I'll start the blimp. So this is our first production line, the autonomous blimp, Arduino. We packaged it up on the dining room table. Dale has seen this picture and many pictures like this. This is a very classic maker moment where you make your first kit. And you learn a number of lessons here. Number one, don't put the 6-year-old on quality control. Not only will she not do a very good job, but the customers are remarkably unsympathetic to the missing parts. It's like, oh, but it was a 6-year-old who packed it. They're like, I don't care. It's also possible to pay children, to pay your labor with strawberries and juice. And there's a couple other lessons, like if you're going to sell a kit at a reasonable price, you can't buy the components retail. You have to buy wholesale. And in the course of doing this box is kind of interesting. This box was my motors. And I wanted to buy electric motors, wholesale. So I went to Alibaba and said, can you find people who make motors? I'd like to buy them wholesale. And they're like, yeah, we make motors. What kind would you like? And I'm like, what do you got? And they're like, what kind would you like? And I'm like, just give me your catalog. And they're like, well, actually, that's not the way we work. Here's this little like little form you fill out that tells us what kind of custom motor to make for you. And like shaft length and magnets and windings and voltage and all these various parameters. I just dropped down menus and selected, and I'm like, okay, that's, I guess, the kind of motor we want. And they're like, okay, how many would you like? And I said, I'm thinking about sort of maybe 100. They're like, how about 5,000? The pricing's much better at 5,000. And so I said, how much better? And they're like, it went from like $1 to 17 cents. And I was like, that's pretty good. So I ordered 5,000. And then like 10 days later, they showed up, and they actually worked. And like that was one of those moments, just in the same way that I had those sort of, I got chills when I could get Lego to fly a plane. I got chills when I got robots in China to work for me, and they took PayPal. And I realized that I'm just a guy, you know, and I just commissioned custom motors to be made for me in China. So that was kind of cool. I realized at that point that the sort of, you know, some of the scaling barriers were falling, and it was possible to build businesses using this sort of, you know, what is increasingly the world's supply chains opened to the web. But at the end of the day, the biggest lesson I learned here was that, you know, the only thing worse than failure in the kit business is success, because success means you sell all the kits and now you have to make some more. And I could not get the children to come back to the dining room table. They're like, no way, we're done. They do not make enough strawberries in the world for this. So we had to move to the next step. So I said, Jordy, how about you? This was pizza boxes, of course, a necessary step in a maker evolution. So I said, okay, Jordy, time for you to take this over. So this is Jordy at the beginnings of our company. And it's exactly what you'd expect. Here is hand-assembling boards, soldering iron, in what appears to be in the garage. And this is where I thought it was going to end. I had a day job at Wired, and Jordy was hand-soldering boards to our community, selling them in baggies, you know, in little boxes, and just doing it all himself. And I thought that was the end of the story. And I'm like, great. You know, we've got a community, we're having fun, it's a hobby. If you want to buy it, you can. You know, we've kind of made it easy for people, classic maker moment. And that was the way it went for a few months, and then he sent me another picture. And he said, look, I've got a space. And a couple things jumped out at me about this picture. Well, one, let's see if do I have a laser? I do have a laser. One was there were other people. That was nice. The other was that they had shelves. I was kind of impressed. It's like, you got shelves. And then in the back, he said, oh, and I've ordered a pick-and-place machine from eBay. It was used, and we've got a pick-and-place machine now. Well, the reflow oven was still a toaster oven from Target that was hacked with Arduino. But we had and this guy's name Arturo. He's running the pick-and-place machine. And I was like, again, I had to Google pick-and-place machine. This is the robots that place the chips on the board. And I thought, that's kind of amazing. This guy just ordered a pick-and-place machine, and he downloaded the manual from Google. And then the part that really impressed me was he says, and that's Rebecca, she's our bookkeeper. I was like, wow. We have a bookkeeper. Okay, so at this point I thought, I picked the right guy. He's clearly, you know, doing something here. And then this was the next picture. And this was our San Diego facility, and this is the bigger pick-and-place lines and the bigger reflow ovens, and now it's not a hacked toaster oven from Target anymore. It's a proper Mancorp reflow oven, and there's a stencil printer and CNC machines, and there's Arturo again, but now he runs a team, and this is last year, and at this point, and by the way, it just goes on and on and on, lines and lines of production, shipping, and the impressive thing here, there were two impressive things. One was when they showed me the picture of the big sort of container on the ceiling that has the foam peanuts, and you sort of pull a little cord, and the foam peanuts come into the bag. I was like, oh, that's kind of pretty cool. It also impressed me they had a scale that measured not in grams but in units, so that when they did the kitting, they can just sort of say, here's what one screw weighs, and then it counts screws, so we couldn't get that wrong. But the really impressive thing was when they showed me the forklift. When you have a forklift, you're a real company. So I was like, okay, I got to quit my job. So at this point, the company was about $5 million in annual revenues. Jordy had built a team of about 40 people. We raised a $5.1 million VC round. I quit my job, and today, then we opened our Tijuana facility. This is just one of our clean rooms in the Tijuana facility. At this point now, a couple of things to notice. Uniforms. We have uniforms. And we have, they have electrostatic discharge booties and these pads. And there's ionizers on all the tables. And it is a kind of a controlled clean room facility. And then it was, now the company was about 70 people. Big TJ production, engineering now in San Diego. And then finally, this is where we are today. So this is basically 3 years after Jordy's hand soldering in the garage. There's our TJ facility. This is the new San Diego facility we're just moving into. We're now up to about 75 people. We're going for double-digit millions in revenues this year. And this was done This was done by 25-year-old people who are now 25, who'd never worked in manufacturing before, and it was done because they could. And so I just want to just finish with three lessons about this. First of all, what I learned from my co-founder, what I learned from a teenager who I met on the internet. Number one, he taught me about open hardware, and recognizing that it's not about the right technology, it's about the right community. So we did Arduino, we do Raspberry Pi. We build on the success of the communities of others. We slipstream on where the alpha geeks are going, something that Dale knows very well. Number two, he taught me about manufacturing. This is what teenagers who grew up in Tijuana know. You can build a factory today. You couldn't build a factory 20 years ago, but today you can buy pick-and-place machines on eBay. You can, there's open ERP. A lot of the software is now available to anybody, and it's free and easy to use. You can, all those elements, the shipping, the FedEx APIs, all that stuff has now gotten easy. You can buy forklifts. They just knew this. I had no idea that you could build a factory, but they knew that. They've grown up in a factory town, and they had the courage to just do it. And finally, the important thing is that you would have thought that when the editor-in-chief of Wired co-founds a company with a teenager from Tijuana, that is an unusual pairing at best. But it turns out to be our secret sauce. Tijuana is the Shenzhen of North America. I used to live in China. Family was in Hong Kong, and I spent my time in Guangdong, and I saw the Hong Kong-Shenzhen nexus. And there's glimpses of that in the San Diego Tijuana nexus. Tijuana, every flat screen you have was made in Tijuana. The Foxcons, the Samsungs, the Sonys, the Panasonics, they're all there. These are massive factories doing electronics assembly. Tijuana is twice the size of San Diego. Mexico graduates more engineers than the United States. You want to hire someone who's been working at a world-class electronics assembly plant at ISO 9001 qualifications in the United States, good luck. Tijuana, there's countless of them. We hire people who've been spending the last 10 years working for Foxconn, and they teach us what everything Foxconn knows. That's the secret to doing manufacturing in North America. That's how we compete with China. Our competitors in the drone space are mostly Chinese. They have fantastic engineering and fantastic production. At the high end, they serve the PLA, the Chinese army, and they have engineers that are optimized for that. And at the low end, they use basically the smartphone production facilities of Shenzhen. That's our competitors. They're unbelievably good. They're cheap, they're incredibly good engineering. They're not copying anymore. They're doing not just great technology, but great marketing, great branding, great design, great distribution. How do we compete? And the answer is, I think, our secret weapon, our Mexican connection. We have reached price parity with China on production. Net, we can make things, electronics especially, for the same price as the Chinese. So we think we've equaled them on that. Shorter supply chain means much more flexible, much faster, nimbler R&D. But where we think we can beat them is on innovation. We have a community-based innovation model. We're an open source project. The only thing cheaper than Chinese engineers are free engineers. And if you structure a community right, you basically get the smartest people in the world working for the community for free, driven by their passions, not their paycheck. That, I think, we'll see, but that, I think, is the way to compete with not only Chinese competitors, but also the biggest aerospace companies in the world by using open innovation as a way to not only be cheaper, but also faster. So just to finish, I'm now 140 days into my new job, and I'm slightly sad to report that my strategy is to leave DIY behind us. We started as a maker company. We started putting bags, boards in bags, parts, kits, soldering irons required. And we realized that ultimately, if we're going to change the world, if we're going to turn drones into something that you think of tomorrow as farm equipment, doing crop surveys, that you see them everywhere in an industrial capacity, very low price, very high capability, that we're going to have to take the complexity out. So the first thing we did is we banned the soldering irons. And then the next thing we did is we took things out of bags and we started putting them in enclosures. And now we're starting to eliminate kits. And we're just going to go from the sort of, the Apple I, with the circuit board, with the, the plywood shell, to the Macintosh. That's the pivot we're doing. We're still going to be open. We're still going to be hackable, but you won't have to hack it. And I think that fundamentally, that pivot from the sort of the DIY, the kit, the kind of geek orientation, to anybody can use it. You just open the box and it works. The sort of the iPhone-like experience is what we're going to need to do to have the kind of market and social impact that we want. And that is a serious challenge. We have to change our culture. We have to change our products. It's systems integration on the hardware side. It's systems integration on the software side. It's documentation. It's support. It is a totally different kind of company. And it's going to take us a while to do that. You're going to see some products coming out in July that reflect this. But I think that that is a necessary step. We saw MakerBot do it. MakerBot is kind of one of our heroes. We saw them go from, I have one of the first MakerBots, I think 380, and it was a kit, a bag of parts, you had to solder the board, wires everywhere. And today the Replicator 2 is basically a microwave oven. It just you plug it in and it works. That pivot from kits to plug and play, it just works, is I think a necessary step. It's why we raised the money. It's why I came on as CEO. It is going to be a challenge to get the balance right between the open innovation and the sort of vertically integrated and easy to use product. But we take heart from the experience of MakerBot and others, and we'd like to see more and more companies come out of the maker movement and become mainstream. My Pebble watch here came out of the Kickstarter movement, and today has that kind of mainstream appeal. It's a hot product, it's a hot category. We'd like to do the same for drones. And over the next 6 months, you'll be able to see whether we pulled it off. Thank you very much.